This video looks at two more probability rules. We already looked at the rule that says that something in the sample space has to happen, and the other rule that nothing can happen less often than never or more often than always. And this is the third rule, the complement rule. For any event A, the probability of A plus the probability of its complement equals 1. The consequence of this is if you know the probability of AC, you could find PA by subtracting. The probability of A would be 1 minus the probability of AC. Or you could find the probability of AC by subtracting 1 minus the probability of A. So if you know one of these probabilities, you can find the other by subtracting from 1. Here's an example. If you select a random number from the whole numbers from 1 to 10, you could let event A be that we draw a prime number. The sample space is the whole numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In event A, the prime numbers are 2, 3, 5, and 7 from this sample space. And the complement of A would be the set 1, 4, 6, 8, 9, and 10. Now the probability of A you can get by counting. There are 4 outcomes in A, and there are 10 outcomes in the sample space. So the probability of A is 4 out of 10. In AC, there are 6 outcomes, and so the probability of AC, the complement of A, happening is 6 out of 10. So the probability of A plus the probability of A's complement is 0.4 plus 0.6, which is equal to 1. Now, there's a basic reason why this has to be the case. Any outcome that is not in the event A has to be in the complement, and between the two of them, they contain all of the outcomes in the sample space. And since something in the sample space has to happen, these two have to collectively exhaust the sample space, and therefore they have to add up to a probability of 1. You can complete these statements on your own. I'll pause the video for a minute, and you can answer these questions, and then we'll come back to it. If the probability of B is 0.3, the probability of B's complement is 1 minus the probability of B, which is 1 minus 0.3, which is 0.7. If the probability of B is 0.45, then the probability of B's complement is 1 minus 0.45, which is 0.55. And if the probability of the complement of B is 0.16, then the probability of B is 1 minus 0.16, or 0.84. That's a very simple rule. It's very easy to use. The two probabilities have to add up to 1, so 1 is 1 minus the probability of the other. And it's very simple to use. There is an important extension of this rule. Oftentimes you're going to be asked, what is the probability of getting at least one of these outcomes? And in some situations, these outcomes might have different probabilities, and there might be several of them. In situations like that, it might be easier to find the probability that none of those outcomes occurs, or none of those events occurs, and subtract it from 1. So this is a very useful extension. You'll have lots of occasions to use this, and it can save you potentially a lot of time. Conversely, the probability that none of these outcomes happen, or none of these events happens, is 1 minus the probability that at least one of them happens. But typically, you're going to use the first of these two extensions. You'll be asked, what is the probability that at least one of these events happens? And you will find the probability that none of them happens, and then subtract that from 1, and you'll have your answer in a jiffy. Whereas if you try to find the probability of each of those events separately, and then combine them somehow, you might find that that's a lot of work. So this can save you quite a bit of time. So keep that in mind as we go through the unit. The second rule we're going to look at is the addition rule for disjoint events. I'm calling it Rule 4a. There is another part of this called Rule 4b that we'll look at soon. And this is the rule for the addition rule for disjoint events. It says that if we have any two disjoint events, A and B, the probability of A or B happening is the probability of A plus the probability of B. Now remember, this is the probability of, right here, this is the probability of A union B, or A or B. Okay, and that's an inclusive or typically, but this would mean A or B, or both. But since the events are disjoint, the both cannot happen. So to find this probability, we just add the probability of A plus the probability of B. We don't have to worry about the probability that they both happen. Now here's an example. If A and B are disjoint events, the probability of A is 0.24 and the probability of B is 0.37, then the probability of A or B is just the sum of those probabilities, 0.24 plus 0.37, which is 0.61. If A and B are disjoint and the probability of A is 0.19 and the probability of A or B is 0.72, we can find the probability of B by subtracting probability of A or B minus the probability of A, which is 0.72 minus 0.19, or 0.53 in this case. And you can try these three on your own. You can pause your video and try them out, and then see what you get, and then start your video up again. Welcome back. We're given the probability of A is 0.17, the probability of B is 0.32. To get the probability of A or B, just to add, they add up to 0.49. If you know the probability of B and the probability of A or B, you can find the probability of A by subtracting. 0.65 minus 0.38 is 0.27. And if you know the probability of A and the probability of A or B, you can find the probability of B by subtracting. 0.56 minus 0.42 is 0.14. So hopefully those worked out well for you.